Okay, YouTube, in this video we're going to focus on the inverse of a square matrix. Okay, and so let's go ahead and start with our definition here. We say let A be an n by n matrix. So the first thing we want to write here is this: A must be square. That is to say that we have to have as many rows as we have columns in this matrix in order for an inverse to exist. So we say let A be an n by n matrix, and let I subscript n be the n by n identity matrix. So we say that if there exists an inverse matrix, and we'll write this as A inverse, then we have this truth. And that is to say that A times its inverse matrix, A inverse, gives us the identity matrix, and A inverse times its matrix, A, would equal the identity matrix. So we say that the identity matrix is unique in and of itself, but inverse matrices, when multiplied, give us the identity matrix. So that'll be our check there. So some notes here. We say a non-square matrix cannot have an inverse. It must be a square matrix. And also this, not all square matrices themselves have inverses, okay? So when we talk about inverse matrices, let's go ahead and write a few things here. We say A negative 1. This is read as A inverse, okay? And we just refer to that as our A inverse matrix there, or inverse matrix of A, okay? And also, if we take A inverse times itself here, we get the same thing as if we take A times A inverse. It doesn't matter what order. We always get the identity matrix of order n, whatever these square matrices have orders of. So what we're going to do is we're going to talk about finding the inverse of a square matrix in these examples here. And so let's just start down here where it says finding the inverse of a matrix. Now this right here, I want to be clear on this. This only works for 2 by 2 matrices, this formula I'm about to share. But it says, given some matrix A that is specifically a 2 by 2 matrix, then its inverse is 1 over AD minus BC, all, times, or this scalar here, times all of this stuff on the inside. So we had initially ABCD. What I want to recognize here is this: to find the inverse matrix, what we're going to do is this. We are going to, 1, switch the entries on the main diagonal. Entries on the main diagonal. Now when we say the main diagonal, this is the one that runs down this right here. So you'll notice that A and D here, what happens is their values just switch around here. And then what we're going to do is this: we're going to negate the opposing diagonal. Now the opposing diagonal is the one that just runs the other way. So opposing, I hope I spelled that correctly, diagonal. But if we negate the opposing diagonal, you can see that this is negative B and negative C, and over here we started with the matrix having just B and C. So we switch the main, negate the opposing, then there's this last bit to take out here, to carry out here. We say multiply by the reciprocal, or by 1 over AD minus BC. In other words, the product of the main minus the product of the opposing. So if we want to find the inverse of this matrix up here, that's what we're going to do here. We notice we have our A, B, C, D. What we're going to do is we're going to say that this is our matrix A. And so A inverse, by definition, is equal to 1 over AD minus BC, all times this matrix here, where what we're going to do is we're going to switch the entries on the main diagonal. So where we had a 1 and a negative 3 respectively, now we're going to have a negative 3 and a 1, and those get switched around. And where we had a positive 4 and a negative 1 respectively, we're going to negate these to make this a negative 4 and a positive 1. So now, in order to find this bottom portion here, this AD minus BC, you can see how it's the multiplication of this AD minus the multiplication of the opposing diagonal. So we would say 1 times negative 3, 1 times negative 3, minus now 4 times negative 1, AD minus BC. And so in this case, we get this. We get negative 3 times a positive 1 is a negative 3. Here we get a negative 4. Negative 3 minus a negative 4 is plus a positive 4, and we get a 1 down here. So in other words, we get 1 over 1 times this matrix here, negative 3, negative 4, 1, and 1. So this, we're going to give it a name. We're going to say this is A inverse. And I'm going to put a box around this because the first thing I want to check is, excuse me, if I multiply A by A inverse, do I get the identity matrix? So let's do this. We say 1, 4, negative 1, negative 3. If we were to take this here times the matrix here that we found was its identity or its inverse matrix, negative 3, negative 4, 1, and 1, would we get the identity matrix? And so I know that I get a 2 by 2. The reason why is because we're taking a 2 by 2 times a 2 by 2. The inner dimensions match, and we get the outer dimensions as the dimensions on our new matrix, or the order on the new matrix. So let's go ahead and do this. We'll do some mental math. We say 1 times negative 3 is negative 3, plus 4 times 1. So negative 3 plus 4 is 1. So now moving over first row, second column. First row, second column, we'll do first row times second column. So first row, 1 times -4 is -4, plus 4 times 1, which is +4. -4 plus +4 is 0. So now we'll do second row, first column. We would get this here, second row times my first column. We would get -1 times a -3, which is a 3, plus -3 times 1, which is -3. So a +3 plus a -3. A +3 plus a -3 is 0. And then last but not least, our second row, second column, we say we take our second row times our second column. We'll take -1 times +4, which is 4, plus -3 times 1, which is -3. 4 plus a -3 is 1. So we do indeed get the identity matrix of order 2 when we multiply these together, and that'll be our check to see if that they're inverses here. So really quickly here, I want to take a look at this one here. It'd be good to pause the video and try this on your own really quickly here. But we say if this is a matrix B, let's see, 3, -1, -2, and 2, and we want to find B inverse. Again, what we're going to take is 1 over AD minus BC, where we'll rewrite this matrix here where we switch out the main diagonal. So now it'll be 2, 3, and then the opposing will be negated. So this will be a +1 and a +2, and this is all over 3 times 2. So we get 6 minus -1 times -2, which is 2. So we end up here with 1/4 this matrix here. Now, I would say that when you write the inverse matrix, it is very appropriate to write it as this. And we'll go ahead and scalar multiply through. So we get 2/4, 1/4, 2/4, and 3/4. And yes, anything we could simplify here, including that 2/4, that set of 2/4, we call this a half and a half here. We get a fourth here, and we would get 3/4 here. And this would be the inverse matrix. So one thing I want to do before we move on to this next example, excuse me, is to go into our matrix menu. And I want you to notice this here, matrix B. If I type this in B, this is the matrix that you see here. B is 3, -1, -2, 2. So in order to find the inverse matrix on a calculator, what we'll do is we'll actually just type in B again, so matrix B, and what we're going to do is we're going to find this x to the -1 key. And if you hit that right there, for real numbers it finds the reciprocal, but for matrices it actually finds the inverse. And so you'll notice that I get 0.5, 0.25, 0.5, and 0.75, which are the same values I get over here as fractions, which I like the fractions better. But in this case, if you want to change these into fractions, what you do is right after you get your answer, you go into your math menu. This button here that says math, and the first option says convert my answers to fractions. So if I say take my last matrix answer and convert it to fractions, we get this matrix that you see right here. So in terms of finding inverse matrices, there's one more that I want to take a look at here, and we'll call this matrix C. In matrix C, I've got written down as 1, -2, -4, and 8, and I want to find the inverse of this. And so C inverse, by definition, would be equal to 1 over, now our AD minus BC, times switch out your main, so we'll have an 8 and a 1, negate your opposing, so we'll have a 2, +2, and a +4. And when we multiply these, we get 8 times 1 down our main, minus -2 times a -4 is a +8, so 8 minus 8. So what I want to do right here is I want to write this down. We're going to say this is this times 8, 2, 4, 1. So what this means is that C inverse does not exist because this value down here is 0. So we'd say is undefined. So this would be a case of a matrix here that has no inverse. And the reason why is because it is what we call a singular matrix. Now, when we talk about determinants, that'll come more into play. But basically, a singular matrix is a square matrix that has no inverse. But that's how you find inverses of a 2 by 2. We'll use this formula. Everything bigger than a 2 by 2, we'll use a calculator. Cheers.